Good afternoon, all, for this session on steps to build big data career. My name is Krishna Prasad, well known as KP. I have close to 22 plus years of experience in serving various global clients on data and analytics solutions, and mainly so providing to the Wall Street some of the top financial institutions where big data solutions are one of the core focus area. So with that, let's jump into what is the agenda for today. So we'll cover a bit on who is the data engineer and what do a big data engineer expected to do, and what are big data engineer responsibilities in the day-to-day life as they build the applications to meet the business needs. And what are the big data engineer skills, what are the skills required for him to really become a data engineer and help the business. And finally, yes, we want to learn the skills, we learned what exactly you need to do, but what is the learning path? Because we want to know, if you do Google, there will be 10,000 tools, 10,000 various flavors of big data that you will be seeing. So is there a streamlined way of learning available, and what are the paths available for you to take that journey forward? Okay, this is the broad topics. So who is a big data engineer and what exactly is expected to do? If we take out this, right, who is a data engineer? And I will just take you back a bit on what exactly data, why is it so important, and why we are talking about it so much nowadays. Okay, if you go back to the 90s, let's take the example of a car manufacturing. If you want to buy a car in the 90s, what are we exactly doing? You go to a car manufacturer and find out whether car A is good, car B is good. So you know there is a trusted manufacturing company, distributor, or your local garage person whom you know, and then you take a decision, which means the business tycoons, their job is just manufacture, find out who are the right stakeholders, where they need to go and sell the car, and then their job is done. The remaining is their profit. Okay, it's very simple, straightforward. And as the world moved from 90s to 2000, 1990s to 2000, one of the biggest shift is people stopped going to the car manufacturers and the trust went on to the professional solution providers. It could be the team BHPs and others, where all the manufacturers need to tie up with these professional service providers. So they need to provide more data about how their cars are much better compared to the competition, which means I started only knowing about my car in the beginning in the 90s. 2000s, what happened? I need to know about my competitors' versions also better and prove my car is better than my competitors. Okay, I'm just taking car example. It's true with majority of the other things. So what happened? The decision making of a user moved away from me as a manufacturer to a third party professional. You see how the industry or the user base decision making is putting pressure on the manufacturing side of it. Okay, so that has put more thrust on data, where I need to collect my data, my competitors data, and make sure I build a proper use case why I am better. Which means if I'm collecting 1 GB data in earlier, now I'm collecting 10 GB, 20 GB. It improved more. And then the kind of data I'm getting, earlier I'm collecting only from my units, my company units where I have control. Now I need to go and find out from market players where I still have some control. I will gather that data and then try to provide the results. Now come 2010 or 2015 and way forward, we are not taking decisions by talking to the manufacturers, by talking to some of these professionals. We are trusting the web-based tools. You go and see in the web what exactly is the feedback from an unknown person whom you don't know whether he is genuine, whether he is giving the right feedback. So the manufacturer's product quality is depending on this unknown vast majority of the users across the globe. So you want to buy a car sitting in one of the corners in India, You might rely for a feedback from Singapore, Sri Lanka, or somewhere in US. Now, how will I make sure I influence in all the channels? It could be through internet, it could be through WhatsApp. There are multiple channels where the data is flowing nowadays. Those are the influencers which are enabling the decision making for a user. What exactly should he buy or not buy? So that being the context, now look at it. Where exactly are we now? We are talking about data engineers who are building your traditional data marts or traditional retail store needs in the earlier cycles of data. Now you need the same professionals to build the kind of platforms which can handle huge volume of data and huge variety of data. So that is the big difference, where a data engineer, which used to be very standard defined terminology earlier, the big data has given a very high ended, I would say, recognition for these people. And then if you look at the current COVID situation, it has given more importance to data because we are all sitting at home across the world, not just in one city, one country, across the world. People are sitting in various locations and taking data. And the driver for that is the data engineer's output, which we are talking about. So that is the importance we are talking here. Who is the big data engineer? Now let's come back to who is a big data engineer. So this data engineer's responsibility is to understand the requirement, develop it, make sure it is tested, and then you make sure it is properly maintained post the production rollout. It's by and large the same thing what you see in the context of any other application if you are already in the IT system, or if you are coming new into the IT world. It is the same thing which you would have seen as a standard software development lifecycle. But why is it important? What exactly is it different when you come into the big data world? Let's look into that. So what exactly does the big data engineer do? So here, if you look into the various steps of what exactly is expected to do, again, I will go back to my earlier scenario, why we need to do each of these things and what exactly is your ETL concept which is coming here. So what do you need to do? We spoke about it. It's a standard life cycle. You get a design, you get a requirement from the business where they say you need to build so and so platform. Then you make a design for that, you develop it, and then and construction is done, and then you install or deploy into the production. Testing and maintenance is part of the scope. So this is the overall scenario. Depending on agile or the standard life cycle waterfall model you follow, you will be doing these steps. Then what is the next step? Build highly scalable, robust, and fault tolerant system. So taking care of complete extract, transform, and load process. So when we are talking about this, let's understand, why do you need to extract data? Why do you need to transform data? Why do you need to load the data? Because you are saying the data is already loaded, which means it is available. So why you are extracting the data and again loading it to somewhere else? What exactly is the need? So for that, I will just give you another example. Earlier we spoke about why the need is there for a big data engineer. Now I will say, what exactly is this big data engineer's responsibility compared to a data engineer? So let's take case of a retail store, any large retail store which you talk. When you go into a retail store, let's say Spar supermarket or Star, one of the biggest challenge that retailers will have is the user experience, okay? Which means you need to give best products available, you should have all the variety available, all kinds of discounts available so that the user experience is good. But the best user experience that you can give a customer when he comes into the retail store is how fast he can exit your retail store, which means I got, let's say, various items worth 10,000 rupees. I come all the way till the your billing counter and I see 100 members standing there. it doesn't work out. So when you are building a solution, billing solution for a retail store, what is the need? Your job is quickly scan that product, make an entry, and then go and make sure this guy is completing his billing and moving out. So your need is just quickly complete the cycle. But look at the other side. If I am a supermarket owner who have 20 stores across various cities or 100 store across various cities in India or across the globe, my need is to find out which store is selling what kind of products, what kind of profit I am making in what kind of seasons, what kind of days. So there is lot of decision making I need to take depending on my investment strategy or depending on how I need to make my supply chain, which means how many products of which company, which product I need to get and keep in my wire store, because wire store is one of the largest high cost investment I need to do. Now, just imagine if I build a billing system which takes care of both taking care of billing and taking management decision at the same time. There is more process running on the same system and it slows down the billing process. So just imagine a guy comes and buys huge amount of stock from you and he's at the billing counter and you say, sir, 1 minute, the billing process is very slow because we are running some management reports for my management to find out if I can serve you better. I think forget about serving him better next time. This time you are losing a customer. So the need is to separate out the transactional systems, which is the billing, and create a separate warehouse where it enables the management to take better decision making. So that is the need where you have 100 stores sitting in 100 different locations. They're all doing different kinds of softwares and products and all. You need to get all the data and keep into this central data warehouse. So the role of the big data engineer with growing demand for data is to create that single data warehouse hub. Okay, it could be in your structured or unstructured way. As the volume grows, you are going to create a big data warehouse sitting here. So the process of extracting the data, which means taking the data out from the each of these retail stores and transforming to make sure they are aligned to your central warehouse data model and loading it back into that central warehouse. So all the 100 warehouses data, you as a data engineer are responsible for this process called ETL, and then building highly scalable, robust, fault tolerant. So you look at the retail guy, you are a data engineer for a retail billing system. You are building highly scalable, robust, fault tolerant to make sure that quick decision making of billing is done. Whereas when you come to the data warehousing side, where you as a big data engineer is building a data hub, your job is to build a very robust platform where you can enable the decision making. At the end, the management or the various operations guys need what exactly decisions they need to take. So your job is to make sure you think properly, do the ETL process, build that warehouse, and give them the best reports for decision making. So the next one, that's exactly what I was saying. You ensure your architecture is planned in such a way that it meets the business requirement. And when we say business requirement, it could be management, it could be your operations team, it could be your warehouse team, it could be your finance team. So different stakeholders in your organization will have different needs. You as a big data engineer need to sit and see, oh, how will I build my data in between, which is the hosting the data, which is called the data hub. How do I extract from various sites the data? How do I build the reporting or analytics layer for my management, operations, and finance system? So at the end of the day, they use these reports for the better usage. Okay, so this is the, if you see, these are very plain bullets when you see on the face of it, but that is the thought process which goes behind what you really do when you get onto the ground to serve your clients. This is the core which establish the what and then what exactly is available in the ecosystem. We'll go to that, which both tying together is what is going to drive your career path. Discovering various opportunities for data acquisition and exploring the new ways. Okay, so what does this mean? This is exactly what we said. When you are sitting as at the management will come and say, okay, tomorrow I want to release this product. What is the better way I can do it? So you as data engineer need to sit and figure out what is it the management is asking. Is the data a relevant attribute which is available within the organization, or is he asking for a product which I need to do by doing some research from third party? So then your entire way you will approach this solution will be completely different. So your thought process, and I would say the analytical process, is extremely important in a big data engineer, because your 70% of your work will be thinking, analyzing, designing. Implementation, you have multiple tools. That's what anyone can provide. But that first process of analytical and design thinking is what is extremely important. Okay, next one, proposing ways to improve data quality, reliability, efficiency of whole system. So what does data quality mean? Maybe we have 100 stores across the globe, and we need data from each of these stores, and then I'm trying to load it into my central warehouse. So everyone will have their own ways of keeping their jargons. The challenge when you go into the globe, everyone use, like someone can spell India as INDIA, someone will say IND, someone will say IN. How do we make sure all of them are coming together and then we are loading into that central warehouse properly with the right data quality? And then maybe some places you don't, you have address with, let's say, 20 lines which cannot fit into your platform. So how do you ensure data truncation is not happening? Because if he is a reliable customer of yours, you don't want to lose one of the voucher going to him. So these are all the data quality attributes which will really drive your decision making, and you need to be extremely careful, because data quality, the quality of the data that you load into data warehouse defines the quality of the business decision making. So if your quality is not good, your decision making is going to be hampered. The next one is creating a complete solution by integrating a variety of programming languages tools altogether. I think at the end of the day, once you decide how you want to put data together, how you want to give the reports to your management, your job is done. Then you need to go and figure out what are the languages available, what is the right one for your organization, what is the right choice, because there is a culture. Some people can be Microsoft shop, some can be Google shop, some can be AWS shop. Depending on that, you have multiple options which will integrate well between these tools. Okay, then creating data models to reduce system complexity. I exactly told this is what is the key. At the end of the day, you as a data engineer are responsible to make sure once the system goes into production, the maintenance guys can easily maintain this platform. Okay, the cost of maintaining this platform should be very simple, and you need to build a very reliable system for that. Okay, if you build a very complex system where no one in the maintenance side understands, just imagine that doesn't work out. It's the same situation like the car, right? You buy the best of the car and you come out and none of the maintenance staff knows when there is a problem how to fix it. It's of no use. Same way, when you build a platform, you need to build it in such a way that you should be able to maintain it easily and hence increase efficiency. Obviously, when you build a better product, your maintenance overheads are less, so you will spend more time in the upfront and reduce the cost. Now, deploying for disaster and recovery techniques. So this is one of the biggest challenge. If I were to go back to your September 11 attacks which happened in the US, the entire Wall Street's data is sitting in a couple of blocks away from the World Trade Center buildings which got collapsed. They have realized that once you lose data, you're nothing today in today's world, right? So it's extremely important when you build these kind of data hubs, which are really enabling your decision making or business decision making tools. You need to be extremely clear and careful on what is your disaster recovery techniques. And introducing new data management tools, as I said, we started in 1990 with some kind of tools, 2000, 2010, and now if you look at it, we started with in-house kind of robust infrastructure. Today, you see the Olas and Ubers. You go and ask them how many servers they have. Zero. They started in the world of cloud. So we came to a good logical stop. What exactly does a data engineer do? Going into big data engineer responsibilities, you have broadly data ingestion, which could be equal to data, your traditional ETL, where you acquire data from various sources and then ingesting into the data lake. Data lake is nothing but your data hub, data lake. These are all the various terminologies depending on the size and the way you operate. But this is the same thing. If you are in the traditional world, it's called a data warehouse. Now, what is data transformation? As I said, you are getting data from various sources. You need to make sure you get them into one format which your industry, your organization understands. And so it is just the making sure you are getting into a qualified data getting from various sources. And understand, when we are talking about data transformation, we are not talking about acquiring data from within your organization. You are going to get from internet and various other channels. Performance optimization, I spoke about it. It's extremely important. Based on your use case, you are trying to get the right performance and right modeling so that it's very efficient and highly maintenance is very easy as you go into the production, as you do post-production. So what are the big data engineer skills? What is a big data framework? So if you were to look at this, so this is your key storage part, where it is equivalent to your, in the traditional world, if you see it, this is called the database. In big data world, where you are getting into the large data volumes where you want to store, the HDFS is the replacement in the Hadoop system. There are multiple others which are available. Now, if you see bottom, these are your ingestion layers. The Flume is one of the tools you have. And if you want to ingest the data from an unstructured or semi-structured source systems, so it could be a Twitter, it could be a Facebook, it could be your LinkedIn, from where you want to, for analysis purpose and storing in HDFS, you use the Flume, which is your ingestion thing. Scoop is another tool which is coming from your structured data. Structured data is as good as your Excel, your Oracle database, your SQL server, and all of these. Now, once you have data stored here, what do you want to do after that? You need to make sure you use a set of tools. This is what you are all asking. So I have the background of functional background, but what are the tools I need to gain expertise so that I can be relevant for the industry or I can enter the industry? I am not going to go deep into each of them, but just highly I will touch upon. So MapReduce is something, because your HDFS, when we are talking, this is not in thousands or lakhs or crores we are talking about gigabytes, petabytes, and zettabytes. Maybe something new came up already, okay? So it's just getting into power 10 to the power of 9, 12, 16, 20. Okay, every year, every quarter, every month, it's just the data size is quite growing enormously with every passing day. Now, this MapReduce is enabled to make sure when you are getting data from the multiple HDFS systems, which is maintained in various servers, you converge the data and give it to the front end business user so that he can take a better decision making. And if you want to read it properly, it is mapping data from multiple servers and reducing it to meet your query requirement for the front end user. So it's a map and reduce, because when you are storing distributedly. When you are answering the question, you need to first map all of them together and then reduce the size of data, like applying the filters, the where clauses and all, and hand it over back to the user. Then he can play with it. Then Hive is one of the SQL like query based language where you can really start doing your analytics. Then one of the starting point to enter into AI and machine learning is big data. This is your basic thing. So Spark MLib is one of the machine learning library which you can use if you're really into getting into the machine learning kind of environment. And Spark, Apache Spark, which you see here, this is a in-memory solution where you do heavy volume processing, right? So, and then Kafka, this is your real-time streaming. So if you go into your Facebook, or if you try to go and if you're driving a car, you keep seeing in your maps, Google Maps, right? It is all high streaming data. It is continuously saying where you are, how you are moving and all. It is streaming data, right? Behind your Google Maps, you see a Kafka, you see a streaming, you see a Spark. These are the ones which are enabling and telling you in that visualization layer what exactly you are trying to do. And then you have the search engine. This is what you see in your Googles and all. These are the search engines behind the scene, because we are talking about, just imagine you go to YouTube, which is massive, and you do just a search, you are finding in just split second. And then just imagine the beauty of YouTube. You play a video, of course, if you are registered, you play a video, you shut it down, go and log into any other from any other machine using your user ID. If you are playing the same video, it will play from where you left. So imagine the kind of data I'm storing for a user in an unstructured world. I'm not talking about structured world. I need to say which millisecond you have ended your video last, and again I need to restart. So such kind of data I'm trying to store, and you are not paying anything to me. So I need to find so many revenue streams to make that this is happening. So this is another stream which we see. And Uzi, this is a scheduler where if you have a job you want to run at a particular time, it will be used. And Zookeeper is the complete management. If you see, it's so many things. They all need to be interacting with each other. And what exactly would you do? You need a Zookeeper who will be a controller for all of these things. This is high level about the kind of various skills we spoke about for you to be a big data engineer. Now we come to real-time frameworks. We spoke about it. The Spark is one of the ones which enables your real-time framework. We spoke a YouTube, a Netflix, the Facebooks, the Twitters. What happens is you are taking your decisions in real time. You don't have time to really go store data in database and then take a decision. I will give you a very clear example. You take the case of Make My Trip. You go and open your booking, and once you make the booking in real time, it will giving you so many options based on what you are doing on the screen. Depending on the date, depending on the place you select, it will be giving you what is the hotel and what are the other options, what are the places you can visit. It is all happening in real time because there is a Spark kind of a real-time processing engine and Kafka kind of another tool which is interfacing behind the scene to give you the results what you are seeing. So what I'm saying is your day-to-day tools what you are seeing are already using some of the things which we are seeing here. So when you are becoming big data engineer, your thoughts should be, are you good at taking real-time decisions? Is that your core? Or are you good at that Google Maps where you can give a better visualization based on what the backend data engineer can give? No, I'm good at data. I can understand what kind of data attributes I can get, what kind of data elements I can get, and then store it in database. I can create high performing, data warehouses and data hubs very well. Then you are in the other side. So these are all the various flavors we are talking about, and you can pick and choose depending on your interest and your area or background from where you are coming. Then DBMS and data architecture. This is our traditional databases coming from your Oracles and SQL servers. They provide the backend of hosting solutions. And if you come into the big data space of unstructured, that's where your Hadoop and then your Azure Data Lake, your Snowflake, the Redshift coming from AWS. So there are multiple other unstructured databases. Now you have a database behind the scene, then how do you interact with them? So an Oracle database, you use your SQL, PLSQL, IBM with mainframe on DB2, PostgreSQL on your entire cloud native solutions, you go there. Oracle and MySQL Server, they are the long time players in the space. Okay, MySQL is one of the open source system on the SQL based technology. So this is your DBMS, your relational databases. These are the ones. So these are meant both for your traditional transactional systems, which I spoke about, billing system, and to a peak of where you can manage to some kind of data warehouses. But once you breach it, Oracle provides Exadata, which is a data warehouse solution. SQL Server on cloud, you have a multi-cluster SQL service solution, and DB2 is more mainframe restricted. It's not yet into the big data solutions yet because it's standing on the other side. Okay, now SQL, when we talk about SQL, it is having a proper structure. You know what to do because you have a proper table defined behind the scenes. But when you get into the other side, what is a NoSQL? NoSQL doesn't mean there is no SQL. So when we talk about SQL, it is a very structured language, right? It's called, the name itself is structured query language. So you say what are the attributes you want to select. There will be a where clause where you write, okay, this is what I want to filter on, and this is how I want to group. It's similar if you are familiar with Excel, how you are playing the pivot. Same thing happens in your SQL. So when you go to NoSQL, it is not NoSQL, it is not only SQL. Okay, what it means is it caters to SQL as well as unstructured data as well. So MongoDB, this is one, and HBase and Cassandra, and then you have multiple other NoSQL databases and even graph databases which come into this, where you either store it as a key value pair, or you can have in JSONs, or you can store in blobs. So there is multiple ways you can start storing these unstructured data, and then the NoSQL databases will help you to provide an interface to retrieve the data and hand it over to the data scientist to enable decision making process. Okay, now just imagine where we started. We started with data. We are talking about big data frameworks. Under that, we have a traditional DBMS, SQL, and NoSQL there only. Then the underlying layer, wherever we are, okay, this is where I told the ingestion can be happening through your ETL frameworks. It could be an Informatica, or it could be a Pentaho, or it could be a data stage, which are traditional players in the ETL space, or in the new world of data ingestion, where we are building data lakes, where everyone is trying to move away from licensing tools to open source. A Python, R, Java, Scala, these are the languages which you can learn. And especially if you are a new aspirant or new entrant into the big data space, coming fresh out of college or coming from other streams into big data, this is something which is extremely interesting. Python and PySpark are the areas which will be your entry points into the big data space. Next is ETL and data warehousing. So as I said, your talents and Informatica, these are all the ETL tools. SQL Server, Oracle Server, these are your data warehouses which we used to build. You have the Click, and you have your Tableaus, which are the visualization layers. So you have a ETL, you have a data warehouse, and then you have a visualization / analytics layer. Broadly, these are the three layers. If you remember and if you understand, you have a talent, which is the or Informatica, which is ETL layer / ingestion layer. Then you need to store the data, which could be SQL Server, Oracle, or your HDFS, which we saw. And then we are talking about a ClickView or a Tableau, which are your analytics layer. These are broadly the three layers. So where you want to build the career, we will see as we go forward. Okay, then obviously the operating system, I think by and large, you need not worry so much, because most of the current tools and technologies and frameworks are going to make sure you are completely isolated from the underlying operating system. And that is the entire beauty of this cloud, right? They are trying to make sure you move from one cloud to other cloud, or one platform to other platform on operating systems. You are tools or the implementations will not be by and large impacted. There will be minor challenges. However, there is one path of administrator. If you are trying to enter that path, this is going to be your key focus area. So here is what I said. As I said, this is the starting from one journey line to complete your journey line. What are the various things which we spoke already about? Do we have all the tools? No, but these are some of the starting point for you to understand. We spoke about programming language and operating system. We spoke about DBMS and SQL. We spoke about NoSQL databases, ETL and data warehousing, big data frameworks, real-time frameworks, and cloud. So whatever we covered in the past, all the way till real-time frameworks can be on-prem, which means in your company, in your place, you will be storing the data or all these tools, or it could be on cloud, which means it is not in your premises. It is sitting on the AWS data center or Azure data center, or in, if you are going into Google, a Google cloud. Okay. So this is one of the biggest shift. As I said, the Olas, the Ubers, the all the new players, some of the biggest startups which came in this last 5-10 years, they don't have anything on cloud, on-prem. They all started on cloud, so their investment is very low compared to the stars and multinationals who started long back. They have a different challenge to face. Now, this is the journey path I was talking. We spoke about multiple things. So this is the most important thing you need to understand. If you are coming from a developer background and that is your core focus, when I say developer background, where you want to write code, where you want to write queries, where you want to be in the optimization side of things, okay, where you will be behind the scene, okay, you will not be your code, your data or all the enablers, they are not in front of the customer, but you are very good in making sure you prepare the data so that someone can enable the decision. So you are in the developer testing path. That is where you need to pick the path. If you are amazing in domain, the business analyst, the testing guys, or someone who thinks they have best analytical skills to look at data and derive some patterns out of it, right? Then I will go to the third layer, which is called the data analyst, which is your statistics. Oh, you got this much data. Can I take this data and say who in this next 100 members will act like someone who already is in my system? So that is data science all about. Can you go how patiently do this modeling using statistics and various other layers? So in the data analyst layer, there are two things. One is data science, where you do lot of mathematical things, mathematical algorithms. So that is one side of it. The second side of it in the data analyst is the visualization side. As rightly pointed, you have Tableau, you have ClickView, you have your Power BI. So these are going to be, if you're really very good in creating presentations, drawing pictures, giving a better impact of what data you collected, you need to make sure at the end of the day, the end user is able to connect what data is sitting in your thing. Okay, what kind of decision making are you asking him to take based on the data? So is graph a right one? Is a picture a right one? Is a line graph right one? And there are a whole set of tools available out there, right? So that is what is going to be your key focus area of visualization if you are good in that aspect. So pick one of these based on your interest, and then you can pick one of the which is aligned to your thing, or if you are planning to do it, you can pick based on the thought process we said. Irrespective of which path you are taking, one of the most important thing is you should have an understanding of all three areas. The administrator, this is the guy who is core. He is going to control both top and bottom. What does that mean? He's going to say if the data, if there is a challenge, administrator is the guy who will say, oh, developer, he loaded the data, analyst is having a challenge. If these two have a challenge on any side, they both to talk saying, okay, I have a performance issue in between. The administrator is a key guy. He need to make sure the clusters are created properly, the space is available properly, a proper expansion, which you mean the virtualization is done properly, both horizontal and vertical. We need the entire playing field as developers, as data analysts, as visualization engineers to have the right platform. Administrator is the horizontal sitting and making sure you don't fail as you start developing, building, and creating visualization layers. So that's about my entire slide and presentation. Okay, thank you everyone. I hope I gave you the industry view, what exactly are the various flavors that's happening in the industry, and which are the paths you can pick. Thanks a lot for taking your time. Hope it's useful. Wishing you all good luck.